the summer of 1941, the German army appeared unstoppable. For 2 years, its armored divisions had carried a new kind of warfare across Europe, overwhelming Poland, France, and the Low Countries with fast-moving columns of tanks supported by aircraft and infantry. The Panzer III and Panzer IV, the backbone of these formations, were not the heaviest machines on the battlefield, but they were reliable, well-organized, and handled by crews trained in a doctrine of speed and coordination. Victory seemed to belong to whoever moved fastest. Then, on the 22nd of June 1941, Germany invaded the Soviet Union, and within weeks, that confidence met something it had not anticipated. Along the roads of the Eastern Front, German gunners began to encounter Soviet tanks that behaved unlike anything they had faced before. The T-34, with its sloped armor, wide tracks, and powerful 76mm gun, could cross mud and snow that bogged down German vehicles, and its angled plates deflected shells that would have pierced flat armor. The heavier KV-1 was even more troubling. German crews reported firing round after round at close range only to watch them ricochet away, leaving the Soviet machine to roll on. The standard German anti-tank guns of the period, the 37mm and the short 50mm, were nearly useless against them. For the first time, the tank that had defined German success was outclassed in armor and firepower by the enemy it was meant to defeat. The problem the German command now faced was specific and urgent. They needed a tank heavy enough to survive the fire of these Soviet machines and armed with a gun powerful enough to destroy them at ranges beyond which the enemy could reply. It had to carry armor thick enough to resist direct hits to the front and a weapon accurate and hard-hitting enough to dominate the long, open distances of the Russian plain. Such a machine would be far larger and heavier than anything Germany had yet fielded, and building it would test the limits of the country's engineering and its factories. The idea of a heavy breakthrough tank was not new in 1941. Since the late 1930s, the firm of Henschel & Son in Kassel had been quietly experimenting with heavier designs under contracts for what was called a breakthrough vehicle, producing a series of prototypes that never entered production. These projects had remained low priorities while the lighter tanks won their victories. What changed everything was the choice of weapon. The German 88mm anti-aircraft gun, the famous Flak, had already proven in France and again in Russia that it could destroy any tank in existence at great range. In 1940 and 1941, batteries of these guns, depressed to fire horizontally, had shattered French and Soviet armor that nothing else could stop. The decision was made to build a tank around a version of this gun, and the requirement crystallized into a single demand: a vehicle of some 45 tons carrying an 88mm cannon. Two firms were asked to solve this problem, and in a coincidence that echoes through the history of engineering, they arrived at radically different answers. The first was Henschel, whose design team was led by Erwin Aders, a careful and experienced engineer who favored proven conventional solutions. The second was the design office of Ferdinand Porsche, already famous, well-connected, and confident to the point of certainty that his approach would prevail. Porsche was a man of bold ideas, and for his tank, he proposed something unusual: a pair of air-cooled gasoline engines that would not drive the tracks directly, but would instead generate electricity to power electric motors at the rear. It was an elegant concept in theory, sparing the crew a heavy mechanical transmission. In practice, it demanded large quantities of copper, a metal in short supply, and it introduced a web of complications that would prove difficult to master. Henschel took the opposite path. Aders and his team built their tank around a conventional layout, with a single engine driving the tracks through a gearbox, favoring components that mechanics in the field could understand and repair. Both machines would carry the same devastating weapon, the 88mm tank gun known as the KWK-36, derived directly from the anti-aircraft gun, and capable of penetrating the armor of any Allied tank at distances of well over a kilometer. Around that gun, the two firms wrapped their steel in very different ways. The tank that Henschel produced was a machine of massive proportions. Its frontal armor was 100 millimeters thick, its sides and rear 80. Plates of rolled steel welded into a hull and turret that together weighed more than 50 tons in combat trim, far beyond the weight of any tank Germany had built before. The armor was flat rather than sloped, unlike the T-34 that had inspired the whole effort. But it was so thick that most enemy guns could not defeat it from the front at any normal range. The turret held the long gun, and 3 of the 5 crewmen, the commander and the gunner and the loader, while the driver and the radio operator sat forward in the hull. Power came from a Maybach 12-cylinder engine, a gasoline unit producing around 650 horsepower in the earliest vehicles, later increased to roughly 700, straining to move the enormous mass at a road speed of only about 40 kilometers an hour. To carry that weight without sinking into soft ground, Henschel adopted a suspension of overlapping and interleaved road wheels, arranged in rows that nested into one another across very wide tracks. The system spread the tank's weight over a large area and gave it a remarkably smooth ride, but it carried a hidden cost. Mud and snow packed between the wheels, and in the Russian winter, it could freeze solid overnight, locking the tank in place until the ice was chipped away or thawed. The tracks themselves created another difficulty. They were so wide that the finished tank was too broad to fit within the loading limits of European railways. To move a Tiger by train, the crew had to remove the outermost road wheels and fit a set of narrower transport tracks, then reverse the whole laborious process on arrival. A tank designed to dominate the battlefield could not easily reach it. There were other refinements born of the machine's sheer size. Because the Tiger was too heavy for many bridges, the earliest production vehicles were built to wade through deep water, sealed well enough to ford rivers several meters deep with the aid of a tall breathing pipe, while the crew sat submerged inside. It was an extraordinary capability for so large a machine, though it was rarely used and quietly abandoned on later tanks as too costly to build into every hull. The decision between the two designs came on the 20th of April 1942, at Hitler's headquarters in East Prussia, on the occasion of his birthday. Both prototypes were brought to a rail siding near Rustenburg and put through their paces before the assembled officials. The comparison did not favor Porsche. His electrically driven machine proved troublesome and difficult to handle, while the Henschel tank, for all its weight, ran more dependably over the course laid out for it. Henschel's design was chosen for production. Porsche had been so certain of winning that he had already ordered the manufacture of around 90 hulls for his version. Rather than waste them, these were later rebuilt into a heavy tank destroyer that would carry the same 88mm gun in a fixed superstructure. Production of the winning design began at the Henschel Works in Kassel in August 1942. The first vehicles came off the line slowly, for the Tiger was an immensely complicated machine to build, assembled with a care and a quantity of labor that made it roughly twice as expensive as a Panzer IV and far slower to produce. Every tank swallowed enormous resources and hundreds of thousands of hours of skilled work, and each one that left the factory represented raw materials and man-hours that might otherwise have produced several lighter vehicles. In its purpose, it resembled the very Soviet tanks it was meant to counter. Yet in method, it was their opposite. For where the T-34 was designed to be built simply and by the tens of thousands, the Tiger was a weapon of quality that could never be produced in such numbers. It was, from the very beginning, a machine that asked a great deal of the country that made it. The first Tigers were rushed into action almost immediately, and the result was a lesson in haste. In September 1942, a small number were committed near Leningrad, in a landscape of marsh and forest that was almost perfectly unsuited to a heavy tank. Confined to narrow causeways where they could not maneuver, Several broke down or bogged in the swamp, and the debut that was meant to demonstrate the new weapon's power instead exposed its mechanical immaturity and the folly of deploying it on ground that trapped it. One would later be captured nearly intact by Soviet forces, handing them a detailed look at Germany's newest secret before it had properly proven itself, and giving their own designers a head start in preparing the guns and tanks that would answer it. In time, the Tiger would earn a reputation out of all proportion to its numbers. On open ground suited to its strengths, where its gun could reach out and its armor could shrug off return fire, it became one of the most feared weapons of the war, and Allied crews learned to respect the long barrel and the boxy silhouette from a great distance. Yet it was always rare. Between the summer of 1942 and the late summer of 1944, only about 1,350 were ever built, a tiny figure beside the tens of thousands of tanks produced by the Soviet Union and the United States in the same years. The Tiger was a machine of formidable power and persistent frailty at once, expensive, demanding, mechanically delicate for all its armor, and forever too few to change the outcome of the war. Something of that machine still survives. In a museum in the south of England at Bovington sits a tiger captured in Tunisia in the spring of 1943, restored over many years, and returned to running order. It is the only tiger of its kind in the world that still moves under its own power, and when its engine turns over and its tracks begin to grind against the concrete, the sound that fills the hall is close to the one that once carried across the plains and marshes of a continent at war. It is a reminder of the enormous, flawed, and unforgettable weapon that a handful of engineers in Kassel built in 1942, a machine conceived in a matter of months to answer a shock on the battlefield, and remembered long after the war that produced it had ended,